Today I will be demystifying transformation matrices that are used in computer graphics, 3D computer graphics. Okay, a matrix, it looks intimidating at first sight. It's got 16 values, 4 by 4 values. But what do we use these matrices for in computer graphics? Well, they're called transformation matrices, but really the main thing they do is they just give objects in your software, in your 3D game. They give it a position and an orientation. So let's say we're making a game with airplanes. And we've got an airplane modeled in our modeling software, and it's pointing towards the X direction with its nose. It's flying towards X. The wing directions are in Y, and Z is up. Okay, here. Then in your computer game, you will want to put this plane in your world, in your game world. Okay, so how do we do that? So what we do is, let's say we want to put it on in this position, position 3, 3, 1, which means 3 units forward, 3 units to the left, and 1 unit up. Let's say here we want the plane to end up. And let's furthermore say that we want the plane to be oriented so that it travels in the Y direction. So let me draw the new plane. So here's the new plane. So the plane we've modeled in our 3D software, modeling software, we want in our game at this position and this orientation. Now, we use this matrix to do that. It looks scary, this matrix, but really, let's start by simplifying it. First, you need to know that the last column, that these are all 0, and the bottom one is 1. So this last column we can completely wipe out and write the values 0, 0, 0, 1. Now we've got 4 rows left. The bottom row, let me mark it here, is nothing else than the position. So that position I drew here goes in there. So there are 3 rows left. Let's color code those also. So the top one is just the new forward direction of the transformed plane. So the plane after transformation travels in this direction, and if we look at this vector, it used to the nose used to point in the X direction, but now it points in the Y direction, which means that this vector is 0, 1, 0, and this vector just ends up in this row. And we also have a new Y, and the new Y is this direction, and if we look at it, this new direction of Y is basically pointing in the opposite to the old original X direction. So it would be -1, 0, 0, and this -1, 0, 0 ends up in this row. And then we've got 1 row left. Let's see what this color maybe, which is the new Z. And the new Z actually is exactly the same as the old Z, because the tail is still pointing up. And then we can fill in the 3rd row. So if we take all those values and we fill them in, basically we get our matrix, which is 0, 0, 0, 1 in here. And the new X is 0, 1, 0. The new Y is -1, 0, 0. The new Z is 0, 0, 1. And the position was 3, 3, 1. And here are the 16 values that will take this plane and put it there flying in that direction. So if we take any point on the original model, let's say this point P, then to find out where it ends up as point Q on our position plane, all we have to do is multiply px, py, pz and a 1 appended. We post multiply it with this transformation matrix and we will get the resulting point on this wingtip. So yeah, there you have it. This is what matrices are used for in computer graphics. So just remember, first row is the x-axis, second row is the y-axis, third row is the z-axis, fourth row is the position, and with the column 0, 0, 0, 1. And these matrices will put your objects in your game world, in your world with a position and an orientation.